And when you're doing these projects, you've always got a lot of partners, and so we're no exception. So we've got Shell, a bunch of universities, partners, different institutes. Of course, Boise is our primary partner out there with the paper mill running the project. So we're out here at the paper mill. You guys are, I know you're familiar with this. So here's just a satellite image. This is Highway 12 running along. And our pilot well was right there. So if you happen to drive out there, we started drilling in January of 2009. You would have seen maybe, that drill rig out there. A little hard to spot on that particular site. But why here? Well, because we're sitting here almost in the bowl in terms of the thickness of the basalt sections. At our particular site location, we're thinking it's about 9,000 or 10,000 feet thick total at that site. And underneath us, we probably have another 1,000 feet of sediments that are underneath the basalt. And so we started drilling the well in January of 2009, and we completed that, went down to that 4,110 feet in May. So we finished that off in May. And so there's that line that Charlotte was talking about, and then so there's the well sitting there off the highway. So what you see here, so this is a resistivity log, and when the resistivity goes down, that means there's less water there, so there's less conductivity, and so this would be one of these flow interior sections or a seal. So this zone that we've isolated is really unique in terms of the Regional Carbon Partnership program. We've got these 3 zones which are permeable, but they're separated by these relatively thin basalt flow interior sections. So we're very, very curious about how that CO2 is going to end up interacting, moving, migrating into these zones, which are sparsely fractured. They are, but they're very thin. So the question we want to ask from a scientific perspective is, how does that CO2 then migrate through those sort of fractured rock zones? This is the only place in the world we have a chance to look at something like that. So we're really excited about getting to our injection phase here with the well. So we're at the place where we've submitted our permit to the Department of Ecology. We've gotten a round of questions, and so we're coming back now with a revised application. If everything goes well, I'm hoping we'll be doing CO2 injection out there at the well site about late summer. Just the last couple slides, because I'm definitely getting close to time here. This was a packer system. You can see it here. So it's like an inflatable tire, and this is what we used to isolate the zones as we were drilling down and interrogate the reservoir and get the hydraulic properties as we're going down through. So we isolate that zone, pump water in, pull water out, and so we are able to get the hydraulic properties that we're interested in. And this is a sidewall coring tool. Didn't know for sure if it was going to work at the site. Worked beautifully, yeah, Charlotte? It did. 30 plus cores we got back out, so it worked beautifully. And just little samples, core samples coming back up, all stacked up, and Charlotte's here trying to correlate the well logs with what she's seeing in terms of the structures with the individual little pieces. So that's it. I'll wrap it up. I hope I gave you a little bit of an idea about how we as engineers need to integrate these sequestration systems from the plant to our site. We've got some nice tools that we're working on to help us do that and make it work. We talked a bit about the uncertainties in CAP's sequestration project and how we've got some issues that we can deal with, but there are some strategies that can help us do that. And it's pretty neat being here in the Pacific Northwest. We're making some really unique contributions on the science and underpinnings and really interesting projects that are moving forward the capture and sequestration of CO2.